This is a continuation of the video walkthrough for the Math 143 Semester 2 practice problems. So this question, it's all about interpreting it and understand what it's asking about. Describe how the graph of the function g of x, which equals this negative 1/2 log base 2 of x, this thing, can be obtained from the basic graph. Then choose the correct graph. What do they mean, the basic graph? I can see here that this equation is somewhat complicated, but they tell me about the basic graph right here. They say start with the graph of just plain old f of x equals log base 2 of x. So I can see that hidden right in here. So what does all this other stuff in front do to this basic graph? What's a negative out front do and what's a 1/2 out front do? Even if you don't remember what the graph of an original log looks like, let's think about what numbers do to some function we should really know. If we think about the good old parabola, if we have the good old parabola, which is y equals x squared, well, what happens when you have a negative out front, and what happens when you have a 1/2 out front? Well, let's see what the negative does, and let's see what the 1/2 does. I'm just doing it in that order because that's the order I read it from the equation. So what's a negative do? If you remember, the negative flips it. It takes all the values that you would normally crunch here, and that would become our y value. But instead, you're going to do one more thing to that, and you're going to make it negative. Notice, instead of going up, it went down. Notice it changed the y value. This x squared would be crunched, and that would be my y value. Like right here, the x squared becomes the y value. But we take that x squared, and that's not our y value yet. We have to negativify it, and so it flips it. So that's going to flip it. So I can see already that this logarithm thing is going to be flipped. Now, what else is going to happen to it? Well, what's a 1/2 out front do? Well, if we had this normal y equals x squared, what happens if you stick a 1/2 out front of that? Well, again, that x squared would normally be our y value. However, we are modifying that value. So that's going to be a y value. We're modifying that value by cutting it in half first before it becomes the y. So if you remember, instead of being the normal parabola like this, it's going to make it half as steep because your y values are going to be half their normal value. So that's going to sort of make it like it looks wider, but it's actually what I might call shallower, because technically we have modified the y value. We've made it gone down. Instead of its normal y value, you cut half of it to become the y value. So here we go. Let's check it out. It's going to be flipped, and it's going to be shallower, bringing it down by half. So let's see what our options are. Again, this problem is a little complicated here. It talks about A. We're going to start with that original log, whatever that looks like. Then we're going to blank by multiplying each blank by blank. What? Let's look at our different options here. So this first blank has to do with our options here. Did it get stretched horizontally, shrink it horizontally? Is it we're going to stretch it vertically, or are we going to shrink it vertically? Well, it looks like we're not talking about flipping yet. This has to do with this shallower first. And we see here, we talked about it with the parabola, that it's going to bring it down. It's going to sort of shrink it in the vertical direction. So that is our first option here, is shrink it vertically. Then, what about this other one? It says by multiplying each blank by blank. Well, let's look at those options here. Let's kind of do these both together. Blank by blank. We're going to multiply each. Did we multiply the x coordinate or the y coordinate? Well, if we look over here, I know it looks like we're multiplying the x, but remember, this x squared would normally be our y value because y equals it. But we are multiplying it by half first. So what would normally be a y value up here gets cut in half, and so actually we modified the y value. The same thing is going to happen for the logarithm. Whatever this original thing is, this log is going to give us some y value. Well, before we call it the y value, we're going to cut it in half. So we're actually cutting the y coordinate in half. And we cut it in half by multiplying each y coordinate by, well, we're supposed to write in the correct numerical value. What did we multiply it by? Well, it looks like it's multiplied by half. So it is 1/2. Notice, even here, I don't care that there's the negative there yet. I'm just focused on multiplying by half, which will make the shallowness. And then we're going to do the whole flipping, it looks like. So let's check out the next thing. It says, finally, reflect it across the blank. And our options are the x-axis or the y-axis. Well, remember, we flipped it. We call it flipping it. That negative is going to flip it. For the parabola, it looks like it flipped it. It used to be up here. Now it flipped it down there. Well, what did that really reflect across? It looks like it reflected it across the x-axis. The x-axis separates the up from the down. So it looks like we are going to say the x-axis. It actually reflected it across the x-axis to do the flipping. There we go. That's our answer for that one. Let's continue on. This one is very similar. In fact, look at this one's a good old parabola. So wait, we have this good old parabola here. We're going to describe how to get this graph of this guy obtained from just the basic version. Of course, it looks like here's the basic version, just the good old parent parabola. So now that parent parabola is kind of hidden in there. There would be the x and there would be the square. So what does the times by 3 out front do? And what does that x plus 1 in there do? If you remember, that plus 1 makes it shift to the left 1. And that times by 3 out front, again, is that whole steepness or shallowness. But this time, instead of cutting it in half like we did for the logarithm in the problem before, we're going to times it by 3. So it's going to be 3 times steeper. 3 times steeper. All right, so here we go. Let's read through their situation. So we're going to start with this parabola. Translate the graph blank units blank. Okay, let's check this out. For option A, we need to write in the correct numerical value. Okay, it's gonna translate some number, units blank. Look at the second option. This talks about up, down, left, or right. So wait, how is this one shifting? It looks like we're shifting to the left 1. So it's going to shift, translate the graph 1 unit to the left. And that's our answer. That's how we can read that and try and figure out what they want from us. Let's do the next one. Then after we move it to the left 1 unit to the left, then blank by multiplying each blank by blank. What? Okay. Again, look at our options for this first blank. We're going to stretch it horizontally, shrink it horizontally, vertically stretched, or shrink it vertically. Okay, remember, it was 3 times steeper. That's what they must be talking about. Now, steeper means this parabola, instead of being like this for the normal one, is going to be steeper. And if you remember, that means it's actually the y value going up. So we're actually going to stretch it vertically. We're going to grab this parabola and pull it up. So it's going to stretch it vertically. So that's our first option. Stretch vertically. By multiplying each, okay, are we multiplying the x-coordinate or the y-coordinate? We kind of talked about this before. Since we're stretching it up, that's actually the y value. The y value is 3 times steeper. Instead of going over 1 up 1, it would go over 1 up 3 because it would be 3 times steeper. And that's actually the y-coordinate. We're adjusting the y-coordinate. And so we put y-coordinate. Squeeze it in there. And then how about for that last one? Oh, wait, we're supposed to write in some numerical value, some number. So wait, we stretched it vertically by multiplying each y-coordinate by, well, it's 3 times steeper, so I'm thinking the answer is 3. And there we go. Let's move on to this next style of problem. All right, so this looks like a word problem, and we got 2 parts here to answer. It looks like we're going to have an equation, and it looks like we're going to have to find some dollar amount. So notice I skimmed that before I even read the problem. So a person buys a phone for $150 and signs up for a single line phone plan with 3,000 monthly anytime minutes. Okay. The plan costs $88.57 per month. Write an equation that can be used to determine the total cost of this phone plan for T months. Okay, so notice it's C of T and for T months. So T is like my X value. That's going to be part of my equation. Kind of like some equation with X's and Y's, only it's going to be T's and C of T. Looks like they even started the equation for me. Then find the cost. Okay, so this then part, let's first do the equation. So let's think about this. First, you got to buy the phone, right? You got to buy your phone. That's my phone. And that's 150 bucks. So we're guaranteed to spend at least 150 bucks. Plus, we're going to be spending some more money. We got 3,000 anytime minutes. Okay, I don't think that matters. The plan costs $88.57 per month. Okay, so I'm going to own the phone, but then I also have to pay $88.50 per month, which means I don't just pay this once. I might pay it for another month, and another month, and another month. It looks like T is how many months. So for every month, I'm going to pay this again and again and again. I'm going to pay this multiple times. So I'm going to times this by T. This actually kind of looks like y equals mx plus b. It's just kind of written out of order. So let me put mx plus b. And let me write it in the normal order. So it looks like this is going to be c of t, because we're not using y equals. This is the growth. I'm going to have to keep paying that money over and over. It'll grow for the more months that I'm in. And of course, plus b is the initial value. That's the initial price of just buying the phone for the plan. So there is my equation. 88.57t plus 150. You also could have written it in this alternate order. Doesn't matter. But there is my equation. There's my answer for the equation. Now, then we can find the cost for 18 months, assuming that the number of minutes the person uses doesn't exceed the 3,000 per month. Yeah, because if you go over that, then you probably have to pay even more, like an extra amount. But we're not worried about that. We're not going over that. So let's just actually use our equation. So we could even say it like this, C of 18, because we're doing 18 months. So 88.57 times, pop in the 18, plus the 150 bucks we spent at the very beginning for the phone. I'm actually going to use a calculator. I'm going to go to Desmos.com, and I'm going to just type it in over here. I don't need to worry about graphing anything. 88.57 times 18. I don't need the parentheses, but I'm going to put them there so it looks just like my equation. Looks like it's this much money, $1,744.26. So 1744.26. 1744.26. I believe that's what I said. And so there it is. Notice they have the dollar sign for us. We don't need to round since that looks like perfect amount of money. And there's our answers. All right, here's another situation. Let's see. Looks like a similar thing. Got a phone plan. This is probably going to be my initial amount of money I have to spend, the initial value. It's a 2-line phone plan with 4,000 monthly shared minutes, blah, blah, blah. Oh, the plan costs this much per month. That's how much the expense is going to grow each month. So that's going to be like my slope. And of course, it looks like we're going to use t again. I'm just kind of looking ahead. So there we go. This is kind of like my y equals mx plus b, although if you saw the problem before, the mx is in the wrong order, and then there's the plus b. Looks like we don't need to worry about this next part. Let's just get this equation. Write the equation that can be used to determine the total cost of the plan for t months. So I believe I have it over there. I'm going to rewrite it into y equals mx plus b order. There's my slope times the number of time that it would grow. And then here's my initial value for buying those phones. There's my equation. This next part talks about finding the total cost for 24 months, assuming, again, that we don't go over those minutes and pay an extra charge. So all we got to do is use our equation, this time for 24 months. And then so we just plug it in, plug in 24 months right there. Oops, I was almost going to do another parentheses there. Let's just find out how much money this is. Again, I'm going to go and use my calculator, and I'm going to plug in these new numbers for this particular problem. Looks like $3,000, $3,021. That's an exact amount. So it looks like no change, no pennies. So there we go. All right, this one talks about solving this rational equation. Notice we got fractions here and we got fractions over there on the right side. I even notice we're subtracting some fractions. There's a couple ways to solve this. I always like to deal with it by just getting rid of fractions. So I'm going to space this problem out a little bit so I have room to do some of my work here. Now I also noticed something else. These denominators, like this one's a nice one. I'm going to wrap that in parentheses. That looks like a normal binomial thing, like a factor of something. Speaking of factoring, for this last one, I kind of noticed something down there about it. It kind of looks like this one, but it's got these extra x's. Since they both have x's with it, I can factor an x out. Both pieces had an x, so I pull an x out. And the question is, what would be left over? Well, this was x squared, so that means it had two x's, an x and an x. So it's going to have one of them remaining. And then if I pull that x out, it would just be a minus 2. And then I recognize that it looks like kind of like the denominators from the other guys. So I factored out that second, or really that right side, I should say. I factored out that right side denominator. So it has become this new thing. Of course, I didn't change the top. Now I'm ready to get rid of some of this fraction stuff. This one has this whole binomial here. I'm going to get rid of it by multiplying everything by x minus 2. And I'm going to multiply by x minus 2. And I'm going to multiply by x minus 2. So then I can go, those are gone. In fact, wait a minute. X minus 2 on top, x minus 2 on bottom. Those are also gone. Let me rewrite this thing. Got the 3 there. Now this one has the 3 and the x minus 2. I'm not going to multiply that out yet. This also has a fraction still. And this side also still has a fraction. All I got to do to get rid of those last two fractions is they both have x's on the bottom. So I'm just going to multiply this one by an x, which means I got to multiply this one by an x, which means I got to multiply this one by an x. I multiplied left side and right side, everybody by x. X on top, x on bottom, those cancel. X on top, x on bottom, those cancel. This one doesn't cancel because there's nothing on bottom. So here's my new problem. 3x minus 3 times x minus 2. Looks like all that rest is gone. And this is just what? This is just 6. There we go. There's my new problem. Way nicer. Next thing I noticed is I need to distribute. I should distribute that and distribute that. Problem with this one, watch out when you distribute, is I spaced it out, but this is really a minus 3 times all that. So when I distribute, that minus goes with the 3 into there. So first off, I got 3x at the beginning, right? Let me deal with that, 3x. But then I'm going to subtract 3x times that. So that's minus 3 times that, I should say. And then I'm going to subtract the 3 times this other one, and that's minus 3 times a minus 2, which becomes a plus 6. Okay? And of course, this all equals 6. Now when I go to combine like terms, wait a minute, 3x and a minus 3x, those cancel. So now I just get 6 equals 6, but wait a minute, there's no more x's. 6 equals 6, what? I mean, I could even go and subtract 6 from both sides. Oops, not an equal sign. But subtract a 6 from the left and subtract a 6 from the right. And then I get 0 over here, nothing over here, nothing over here. Now, even back to here where it said 6 equals 6 or when it says 0 equals 0, I noticed that those are true statements. 6 does equal 6. 0 does equal 0. Well, what about x? Who cares about x? X is gone. X has no influence over this problem. The left side is always going to equal the right side. If you remember, that means that x could be any answer. X is a real number. Now, wait a minute. I'm highlighting this answer here because I think x could be anything, but then I notice it also says x is a real number here and x is a real number here. But wait a minute. These two problems up here, these two options, talk about x can't equal 2, can't equal negative 2, or can't equal 2 and can't equal 0. Wait a minute, why would I not want x to equal something? That's because if I go back to the very beginning problem, way at the beginning, These are fractions. And fractions can have a problem. They can go bad. When there's a 0 on bottom, this would be bad. When there's a 0 on bottom here, this would be bad. If we have to worry about an x number that could make this a 0 on bottom. So what could make this be a 0 on bottom? Well, that would be when x equals 2. That would be bad. That would be bad. What would make this be a 0 on bottom? Well, that's just if x was 0, that would be a 0 on bottom, and that would be bad. What about in here? Remember this one we actually factored apart. We factored apart, so in fact, let me rewrite it back over here. I erased it a moment ago. What would make this part be a 0? Well, that's when x is 0. What would make this part, this factor, be a 0? That's when x is 2. So we actually just found two numbers that are bad. X cannot equal. That's why we cross out the equal sign. X could not equal 2 and x could not equal 0. So it actually isn't all real numbers. It's all real numbers except these two bad ones. So we got to watch out. We almost chose the wrong one. We almost forgot that these fractions could have a 0 on bottom, which is bad. This next problem looks very similar. So let's check out that one. Again, we got fractions. I also noticed that this denominator, our first denominator there, looks like that thing can factor apart. So let's try and factor that thing. I can factor with an x and an x. 6 can split into a 2 and a 3 and a 1 and a 6. I'm thinking, looking ahead, that it's going to be a +3 and a +2, because if you FOIL that out, try it out, when in doubt, FOIL it out, and see what I mean here, that this would match it perfectly. And then, of course, I'm going to add, in fact, check it out, look at the other denominators. I'm hoping that an x + 2 and an x + 3 has something to do with this other weird guy, and it does. So let me space these out. I like to wrap these in parentheses. In fact, I like to wrap those top ones as well, because those look like factors. And then let's go here. Of course, I like to wrap that one. Now, we need to get rid of some stuff here. In fact, check it out. This has an x + 2 on bottom, and so does that guy. So I'm going to times everything by x + 2. I'm going to times everything on the left and everything on the right. There's my balance, because then it can cancel out top and bottom. In fact, while I'm at it, I hope you can handle this, but I'm going to get rid of this other one. This has an x + 3 on bottom, and this has x + 3 on the bottom. I'm going to multiply this by x + 3. That's supposed to be a parentheses there. Notice it doesn't really matter which side I put it on. I'm multiplying. You can multiply in any order, on any side. Let me multiply this one by what? X + 3 is what we're doing now, and let's do this one by x + 3. I'll tack it on the end because there's extra room. Of course, x + 3 on top, x + 3 on bottom. Sounds like a nice balance. I can cancel. Those are opposites. Let me rewrite this whole mess. This is getting crazy here. Everything is canceled except for the 3. There's some stuff canceled, but I still have an x + 3. I happen to put it in the front, and an x - 1. There, that one's done. Got my equal sign. Some stuff canceled, but I still have a 7, and I still have this factor. There we go. There's my new problem. Now, how do I solve this? First off, I look on this right side. This looks pretty nice for me to distribute. I can distribute that in right there. So that would be 7x + 14. Now, what about over here? This piece right here, I can FOIL. So I'm going to leave that 3 plus right out there, and I'm going to FOIL this, and then I'm going to have the 3 plus all of the stuff I get when I FOIL. So first would be x squared. Outside, -1x. Inside would be +3x, and then the last would be -3. All right, let's just combine like terms on this left side now. I notice a +3 and a -3, they're going to cancel. And of course, these two guys combine, so I got x squared. One's negative, one's positive though, so they will eliminate each other a little bit. And then of course, I didn't deal with this side yet. Now, what I would probably do is, since we got x squares, we got x's, over here we also got x's, and then we got no x's. That sounds like quadratic stuff. I'm going to get everything to one side, probably over on this side with the x squared. That's nice and normal. So what I'm going to do is I'm going to subtract 7x from both sides. I'm also going to subtract the 14. You can do that in one step. I'm going to do this in 2 steps just to make sure I don't mess anything up. And so now I'm going to subtract the 14, subtract 14. So I get 0 on the right side. And what's on the left side? Looks like I've got x squared minus 5x and minus 14. So I just went right up there. Now how do I solve this? This is a quadratic. We can use any of our quadratic skills. We could factor this thing. We could graph this thing and look for the zeros, also called the x-intercepts. We could do quadratic formula. Based on what I see over here for my options, I think I might try and factor this thing. Let's try it out. So to factor this, what makes the x squared in front? Well, an x and an x. What could multiply to make 14? Well, it could be 1 and 14. Of course, yeah, you might be saying it's negative. Yeah, one of these could be negative. I'm not worried about it yet. Let's see, 1 and 14, we can go 2 and 7. Is there any other way to make 14? In fact, wait a minute. I think I see an option here that works. Why is it that option? Because I have to combine them to make a 5. In fact, a negative 5. If I had a negative 7 and a positive 2, they multiply to make negative 14. But if I also had a negative 7 and I added it with a positive 2, that makes the negative 5. So I think those are my two options. So there's my factors. That's what makes it equal 0. Well, what makes this factor equal 0 and what makes this factor equal 0? Well, when x is positive 7, it would make that equal 0. And if x is negative 2. I think I found my answers. Aren't those the answers? I mean, I feel like those are my answers, but when I look over here, this says x's are any real number, but x cannot equal negative 2 and x cannot equal 3. Wait a minute. I only got two possible answers. I'm not talking about any real answer. Okay, it's not that. Cross that one out. This says x is any real number, except x can't equal 0. Well, I definitely didn't get anything about being any real number. I only got two possible answers. I think the answer is 7 and negative 2. Okay, it's not that. But I am wondering, why are they saying x cannot equal stuff? If you remember the problem before, we have to watch out when there's a 0 on the bottom of these fractions. Now, this is also talking about being no solution. I definitely feel like I got an answer, so I don't think it's no solution. But wait, look at this answer. This answer says x equals 7, which I think is right. I think x equals 7. But what happened to the negative 2? Why isn't negative 2 part of my answer? Well, let's look up here. What would make a 0 on bottom of each of these things? Well, this first one, we actually had to factor it. So what would make a 0 on bottom? That would be when x is negative 3. Oh, that's why they mentioned negative 3 earlier. Or when x is negative 2. That would make that be a 0 because of the factors. In fact, wait, negative 2 would make a 0 on that bottom, and negative 3 would make a 0 on that bottom. So these two things are the ones that are bad. Now, wait a minute. We thought negative 2 was an answer. The problem is that would also make a 0 on bottom, which is bad. So only 7 was the good answer. It was the only good answer because it doesn't make a 0 on bottom. There's our answer for that.